Hi everyone, welcome to GTech Techno Solution Private Limited. Now let's discuss about the use of variables in algebra. So the topics which we are going to cover in this video are variable representation, properties of numbers using variables, and then comes followed by commutative property of addition. Along with that, we'll be dealing with commutative property of multiplication, followed by associative property of addition and multiplication, and followed by we are going to discuss about the distributive property of multiplication over addition. Along with that, we are going to discuss also the expressions with variables and the expressions that is used in terms of practical terms. So let's begin with this. Now let's start with the term which is called as variables. So if you see over here, variables are used to frame rules to find the perimeter of a polygon. The perimeter of a polygon can be obtained by adding the lengths of its sides. You can find here the sides which is represented as S over here. So these are the sides of a polygon. Here the 8-sided polygon is represented for its sides with this variable as S. Now let's see the properties of numbers using the variable. The first and foremost property is all about the commutative property of addition. So if you see about this commutative property of addition, this property states the two numbers that can be added in any order. The two numbers might be, we can consider it as A and B that represents any numbers. So the property is as follows, that is A plus B equals to B plus A. So we have some examples, 6 plus 3 that is equals to 3 plus 6. It's a kind of vice versa concept. So this is all about the property of addition in terms of commutative. Now let's see about the examples in commutative property of addition. So we have the value of A as 2 over here and the value of B as 4. So as the property implies, 2 plus 4 equals to 4 plus 2. So that is equals to 6 on both the sides. So in order to represent, we have 2 apples over here and 4 orange over here. So 2 plus 4 that is equals to 4 plus 2. We have the second example where we have the value of A as 6 and B as 3. So if we add A plus B, on both the sides will be getting a value of 9. So 6 plus 3. So we have 6 cricket ball and 3 football. So 6 plus 3 equals to 3 plus 6, which is represented over here. So this is all about some of the examples of commutative property of addition. Now let's see about the commutative property in terms of multiplication. So if we see about this property in terms of multiplication, so these kinds of property generally states that it will be having two numbers that can be multiplied in any order. If A and B represent any two numbers, then the property is as follows by A into B, which is equals to B into A. So we have some examples where we have 4 into 3 equal to 3 into 4. So the example which we have over here implies that we have 1, 2, 3 and 4. So we have 4 columns and 1, 2, 3. 3 rows. If you check out by this side, we have 1, 2, 3 and 4. 4 rows and 3 columns. So 4 into 3 equal to 3 into 4. It's quite common known that it's 12. So the commutative property of multiplication implies in that way. We have some examples for the commutative property of multiplication. So if we see over here, we have A equal to 2 and B equal to 4. By applying the commutative property of multiplication, we got 2 into 4, that is equals to 4 into 2. That is 8 equals to 8. So we have 8 butterflies. Now let's move on to the next property, that is associative property of addition. So if we see about the associative property, this property states that the three numbers can be added in any order. For example, if we consider A, B and C, that is representing any three numbers, then we can deploy this associative property of addition as A plus B plus C equal to A plus B plus C. By this side we have A plus B, and along with that we are adding C. By this side you can see the same thing with a difference. We are adding A plus B plus C. So this is the logic which will be applying in terms of associative property of addition. It's quite common that even if we add up these two by adding the last term, or else by adding the first term along with the addition of other two terms, we'll be getting the same answer. Let's see some of the examples of associative property of addition. As deployed, we have three terms, that is A equal to 2, B equal to 4 and C equal to 3. So by applying the property, we have the value of A plus B plus C, that is 4 plus 3, which is equals to 2 plus 4, that is A plus B plus 3, that is the C term. So on adding up these terms, the 2 will be carried over here. By adding 4 plus 3 it is 7. By adding 2 plus 4 it's 6. And the third term. So we'll be getting an answer of 9 on both the sides. We have one more example where we have the value A equal to 5, B equal to 4 and C equal to 3. Since A plus BC, you can have a comparison of this property by applying the logic of associative property. So A, that is 5, B plus C, that is 4 plus 3. So this is the value of B and C. In the next side, we have A plus B equal A plus B plus C, that is 5 plus 4 plus 3. So this 5 is carried away to the next step. On adding 4 plus 3 we get 7, 5 plus 4 it's 9 and the 3 again repeated. So on adding we'll be getting the answer of 12 on both the sides. Now let's move on to the concept of associative property in terms of multiplication. If you see about this property, this kind of associative property states that the three numbers can be multiplied in any order. As we discussed, we have three terms, that is A, B and C. So the multiplication of associative property implies A into B equals to implies A into B into C equal to A into B into C. So we have considered A, B and C. So 4 into 2, that is A into B into 3. 3. If you see by this side, A, that is A, 2 into 3, 2 as B and 3 as C. So this is the example of associative property of multiplication. We'll see some of the examples for this associative property. We got 3 terms with the values. By applying the logic of associative property, we'll be multiplying 2 into 4 into 3. By this side, we'll be having 2 into 4 into 3. On multiplying 2 into 4, we'll be getting 8, and the term 3. Over here, if you see, the 2 is carried over here, and multiplying 4 into 3, we'll be getting 12. So we'll be having 24 on both the sides. Similar way, we have one more example. So we'll be multiplying 5 into 4 into 3 over here on one side, and on the other side, we'll be having 5 into 4 into 3. By adding 5 into 4, we'll be getting a value of 20. So the 3 is carried over here. So the other side will be having 5, which is multiplied by 4 into 3, that's 12. So on both the sides we'll be getting an answer of 60. So this is the logic of associative property of multiplication. Now let's move on to the next property, that is distributive property of multiplication over addition. If you see about this property states if A, B and C represent any numbers, then we formalize that A into B plus C equals to A into B plus A into C. So this is the logic of distributive property of multiplication over addition. So we'll see this one. A into B, that is 5 into 6, plus A into C plus A into C. If you see the next side, we have A into B plus C. So the value of A as 5, B plus C, that is 6 plus 4. So we have represented the distributive property of multiplication over addition by substituting the values. You can also find here how the logic of the distributive property of multiplication over the addition is represented over here. If you see some examples for this property, we have A equal to 2, B equal to 4 and C equal to 3. So the value A as 2, which is multiplied by 4 plus 3, that is B plus C, that is equals to 2 into 4 plus 2 into 3. So the 2 is carried to the next step. By adding 4 plus 3, it's 7. That is equals to 2 into 4 as 8 plus 2 into 3 as 6. On multiplying 2 into 7, it's 14. On adding 8 plus 6, it's 14 again. So this is the logic which is there applied between the distributive property of multiplication over addition. We have one more example. We have values A equal to 5, B equal to 4 and C equal to 3. By applying A into B plus C, that is 5 into 4 plus 3, which is equals to 5 into 4, that is A into B plus 5 into 3, that is A into C. The 5 is over here from the first step. Adding these two, it's 7, multiplying 20, multiplying will get 15. So multiplying 5 into 7, it's 35. Adding these two, we'll get 35. Hence, the distributive property of multiplication over addition is represented with an examples. Now let's see some of the expressions with variables. If 5 is added to y, that can be represented as y plus 5. That's over here. If a is multiplied by 8, that can be expressed as 8 into a. So that is 8 into a. If x divided by 3 can be expressed as x divided by 3. So x divided by 3. This is the original representation. First, z multiplied by 2 followed by 5 subtracted from the product. You need to note down this one. That can be expressed as 2z minus 5. So these are some of the examples of how to express the terms with the variables. Hope you got an idea of how to learn the logistics of the use of variables. Thank you for watching from GTech Techno Solution Private Limited.